Welcome back to the another episode of World of Physics. Now in this chapter of magnetism, we are now going to discuss about types of magnetic materials. So as you can see on the screen now, you can see four different types of magnetic materials, that is a paramagnetic, ferromagnetic, anti-ferromagnetic and ferromagnetic material. Okay, so magnetic materials are classified into the different categories based on their magnetic parameters and on whether they carry permanent dipoles or not. So this is the basic, as you can see in the figure A, that is a paramagnetic material. In that the dipoles or the magnetic moments are in a random fashion, whereas in ferromagnetic and ferromagnetic they are in organized fashion, whereas in anti-ferromagnetic equal and opposite directions of can be observed. Okay, in ferromagnetic is there, but the opposition is very minute and smaller. So let us discuss step by step about a paramagnetic material, ferromagnetic material, anti-ferromagnetic and ferromagnetic material. All this will be discussed. But before that, we are going to discuss one more type of magnetic material, that is diamagnetic material. Okay, so it is a magnetic material in which there does not exist any dipole. Okay, so they are repelled by the diamagnetic materials are the materials that are repelled by the applied magnetic field. The permanent dipoles are absolutely absent in a diamagnetic material. So as you can see, in a diamagnetic material, when you apply a magnetic field on the material, the magnetic field surpasses, okay, instead of penetrating in that. So as let us say, for example, of paramagnetic material, in the second case, you can see that magnetic field lines just passes through within the material, but it is very difficult for a magnetic field to pass through a diamagnetic material, because diamagnetic material does not have any permanent dipoles. Okay, all the permanent dipoles are absent in that. So that are the diamagnetic materials. So they are the substance which create a magnetic field in an opposite to an externally applied field. Susceptibility over here is a negative. So these have relative permeability slightly less than a unity. They repel the line of a force slightly. The examples are bismuth, silver, copper and hydrogen. One more important thing is diamagnetic materials are used for making superconductors. So further whenever you study superconductivity, you will find that susceptibility of a superconductive material is equals to -1, because they are highly diamagnetic in nature. Okay. Now next is a paramagnetic material. So what is a paramagnetism? So paramagnetism is a result of a presence of some unpaired electrons and from the realignment of the electron orbits caused by the external magnetic fields. So this material possesses a permanent dipole moment which arises due to an unpaired electrons. In the absence of an external magnetic field, dipoles are randomly oriented, so net magnetization is 0. In the previous case, as we have seen in the figure A, because of the random fashion, net magnetization is 0. As in case of a simple conductor, we all know that electrons are floating. When external electric field is 0, the net current is 0, because electrons are floating in a random direction. So same thing happens over here. Okay. Now magnetic susceptibility is small and it is positive. The permeability is slightly greater than 1. The examples of paramagnetic material are platinum, aluminum, nickel. Okay, so these are the examples of this material. Now next are the ferromagnetic material. So what is a ferromagnetism? So ferromagnetism is a phenomena in which a material gets magnetized to a very large extent in the presence of an external magnetic field. We all know ferromagnetic materials are used for manufacturing permanent magnets. What we do is take a ferromagnetic rod, wound a coil around it, pass a current through the coil. What happens inside the coil? Magnetic field will be produced. Because of the effect of the magnetic field, the ferromagnetic material will get converted into the magnet. So they experience a very strong attractive force when brought near the pole of a magnet. They have a high degree of magnetization and they get permanently magnetized. Permeability is much greater than 1. Susceptibility is high and positive. The examples are iron, cobalt, nickel. Okay, so these are the examples of the ferromagnetic material. So why is that so? Because dipoles are in equal direction. As we have seen in figure B, all the dipoles are in same direction. Next is an anti-ferromagnetic material. So anti-ferromagnetism refers to a phenomenon in which the magnetic interaction between any two dipoles align themselves anti-parallel to each other. Since all the dipoles are equal magnitude, the net magnetization is 0. Whatever the positive force is there, equal and opposite negative force is there. So because of that, the net magnetization is 0. As we have seen in the figure C, the susceptibility is very small and positive. These materials have the temperature dependent magnetism due to the disruption of the magnetic moment alignment. Once the temperature is raised, the alignment gets disturbed. So these the following are the examples are ferrous oxide FeO, manganese oxide MnO, copper chloride CuCl2 are the examples of anti-ferromagnetic materials. So as you can see, the variation of susceptibility with respect to the temperature for 3 types of material is shown. Let us first of all say for paramagnetic material. So with the increase in the temperature, susceptibility decreases. That is seen in the case of paramagnetic material. But in case of anti-ferromagnetic material, initially with the increase in the temperature, as the temperature increases from 10, 20, 30, 40, whatever the range is there, with the increase in the temperature, susceptibility rises, it is increasing. And then after somewhat point, once that particular temperature is reached, then after if you increase the temperature, the curve is now inverted, okay, and then further increase in temperature, the susceptibility decreases. So such a point is known as a Neal point, N-E-E-L, Neal point. It is a point up to which the ferromagnetic materials susceptibility is increased with the increase in the temperature. But after that, with the increase in the temperature, the susceptibility decreases. So that point is known as a Neal point. Now let us talk about ferromagnetic material. So for a ferromagnetic material, with respect to the increase in the temperature, magnetic susceptibility decreases drastically. As you can see initially, with a small increase in temperature, susceptibility decreases drastically or by very large amount up to certain point, that is the Curie point. And then after, with the increase in temperature, susceptibility decreases gradually. Means with a very high change in temperature, high change in susceptibility, low change in temperature, low change in susceptibility. But before Curie point, with a small change in temperature, high change in susceptibility is observed. So this is the variation of susceptibility with respect to the temperature for 3 materials: paramagnetic, ferromagnetic and anti-ferromagnetic materials. Now let us discuss the next type of material, that is ferromagnetic material. So what is ferromagnetism? So ferromagnetism is a phenomena in which the magnetic interaction between two dipoles align anti-parallel to each other. But as in case of anti-ferromagnetic material, the strength was equal, but over here strength is not equal. So they possess a magnetic dipole moment due to the spin of the electron. Okay, so the magnetization of this material is the intermediate between ferromagnetic and anti-ferromagnetic material. The susceptibility is very large and it is definitely positive. Nickel ferrite, ferrous ferrite are the examples of ferromagnetic material. So over here, let us compare this types of material, diamagnetic, paramagnetic and ferromagnetic material, with respect to their various parameters like properties. So the first, by definition, diamagnetic material, we all know it is a material in which there is no permanent magnetic moment. Paramagnetic material has a permanent magnetic moment but in a random manner. Ferromagnetic material has an enormous permanent magnetic moment and in a systematic pattern. Now the spin of the magnet moment or a dipole alignment. So since absence of magnetic moment, there is no spin. Permanent magnetic moment has random spin, and in ferromagnetic moment they are parallel and orderly aligned. So let us talk about the behavior. So the repulsion of magnetic lines of the force from the center of the material, as we all know that diamagnetic material does not allow magnetic field lines to pass through them. It repels them. So there is a repulsion, whereas in case of a paramagnetic and ferromagnetic material there is an attraction. In case of a paramagnetic material there is a little bit attraction, but in case of a ferromagnetic material there is a drastic attraction, means heavy attraction of line towards the center. Magnetized direction. So opposite to the external magnetic field, we know that inside that magnetic field is generated, but that field opposes the external magnetic field, and that is the reason why external magnetic field cannot penetrate to them. So whatever the magnetic field is generated, it is opposite to them. Okay, whereas in case of a paramagnetic and ferromagnetic material, the generated magnetic field is in same direction. Okay. Next is the permeability. So permeability is very less in diamagnetic material, whereas in case of a paramagnetic it is high, and in case of a ferromagnetic it is very high. So similarly, relative permeability is less for diamagnetic, high for paramagnetic, and very high for ferromagnetic material. Susceptibility for diamagnetic material is negative. Paramagnetic material possesses susceptibility as positive, but the value is nearly less than 1. Okay, and for ferromagnetic material it is very high and positive. So that is all about the comparison of magnetic materials with respect to various properties. Okay, so that is for today, guys. So today we have discussed about magnetic materials. See you next session. Thank you. Thanks for watching.